guys, so today we're going to talk about our one and only quadratic word problem. In this word problem, it's going to be dealing with maximums and minimums, so we're going to be using the vertex formula. This is the one and only kind of problem we'll do in this chapter, and it's actually pretty easy because we already have a really nice, simple formula that we can plug right into. So let's take a look. Okay. So of course we're still going to use our same map, label, translate, solve, and answer. But like I said, for these quadratic word problems, we're going to be using the vertex formula during the translation and solving steps. So we learned last week that to find the vertex of a parabola, there's a really nice formula we have. To find the x-coordinate, it's negative b over 2a, and to find the y-coordinate, whatever we get for our x value, we just plug into our function and solve for y. So we have really nice, quick, and easy formula that we can use. So let's take a look at our word problem and how we're going to use this formula. So here's our problem. It says, Bike Co. has determined that when x 100 bikes are built, the average cost per bike is given by C of x equals 0.5x squared minus 0.7x plus 3.401. How many bikes should they build to minimize cost? So you guys know during this stage when I read the problem, I read it 3 times. The first time I just read it. The second time I go through and I highlight anything that I think is going to be sort of important. Okay, so this x 100 bikes, I know I'm going to have to do something with that. All right, so whenever I get my answer, I'm going to have to remember that I need to interpret it as that many hundreds of bikes. Here is my cost function. So the average cost per bike is given by. It's really important that you know how to read this function right here. So C of x, what does that mean? That means C is standing for cost. And we know what x is x 100 bikes. So my x means the number of bikes I have. So the cost of the bikes, okay, to build the bikes is given by this function, 0.5x squared minus 0.7x plus 3.401. Okay, so anywhere I see an x, that means that's the number of bikes. How many bikes should they build to minimize cost? And that's really the key word that's going to tip us off to, oh yeah, vertex. Because we know the vertex of a parabola. Remember, the vertex is a point, okay? Which is why we have an x and a y coordinate for it. So it's either going to be a maximum or a minimum, all right? It's that point in our parabola that is right in the middle. Okay, it's either the highest point if it's a maximum or the lowest point if it's a minimum. And because this parabola is concave up, it's going to be a minimum point. And that's what we're being asked to find. How many bikes should they build to minimize cost? They're asking us for the minimum, the vertex. We know how to find that. We have a lovely formula for it. So let's go to our first step of labeling a variable. The really nice part about this is they're asking us how many bikes. They've already labeled how many bikes with a variable, right? X 100 bikes. This variable x is already standing for the number of bikes. So it already has a variable name, x. And then when we translate it from English sentences to mathematics in our second step, like I said, this is actually a really nice step because we already have a formula. They want to know how many bikes should they build to minimize cost. In these word problems, you will either see the word minimum, minimize, or maximum, maximize, which is going to tell you I just need to use the vertex formula. And since they're asking us for the x-coordinate of the vertex formula, we're going to use this formula right here because we know the x-coordinate of the vertex is negative b over 2a. And now it's just a matter of plugging in b and a. So we'll do that in our next solving step. So here we are at step 3, solve using algebra. Okay, so we know what our a is. Our a is 0.5. We know what our b is. Our b is 0.7. And we actually don't even need c for the vertex formula. It's good to write it. I mean, it's a good habit. We know what our C is, but we don't actually need it for this formula. So we're just going to plug that right into our vertex formula. So we have x sub v equals negative b over 2a. My b is 0.7, so I'm just going to plug that right in. Negative 0.7, silly me. Got to be really careful with those negative signs, right? See, even I do it. And then our a is, of course, 0.5. I can't forget this negative sign out in front, okay? 2 times 0.5, that's 1. These negative signs are going to cancel, so it just leaves us with a positive 0.7. And, of course, 0.7 over 1 is just 0.7. All right? So we got that x sub v, so the vertex, okay, the x-coordinate of the vertex is 0.7. And remember, x is standing for x 100 bikes. So we're now going to need to interpret this a little bit. And remember, the fourth step is so important. It's where you check your answer and you interpret it to make sure it makes sense in context of the question. So let's take a look at this 0.7 bikes that we just arrived at. This word problem offers another really great illustration of why step 4, the interpreting and answering in English with units step, is so incredibly important, right? We need to make sure our answer makes sense in context of the question. And if we look at this, you guys, and we just think about it for a second, we would just immediately realize that there's something fishy about this answer, because what bike company is going to produce 7/10 of a bike to minimize cost? If a bike company produced 7/10 of a bike, they're going to go bankrupt, because you can't, who's going to buy 7/10 of a complete bike? It doesn't make sense. And the key here is really right here in the word problem, is realizing that your units are in x 100 bikes, meaning that whatever we got for our answer, well, we need to multiply it by 100. We need to convert it. All right. So yes, it's 0.7 bikes, but we need to now convert this to be in hundreds. And so what you do when you're dealing with a decimal, you could plug that into your calculator, 0.7 times 100, or you could do this really cool trick, is when you have a decimal point and you're multiplying it by any multiple of 10, right? I shouldn't say multiple of 10, any number, 10, 100, 1000, you count the number of zeros. So here there's 2 zeros, and you jump your decimal point that many places. So 1, 2, and I have a gap here, so I need to put a 0. So that leaves me with 70. So 0.7 times 100 is 70. So actually the bike company is going to produce 70 bikes in order to minimize cost, and that is my actual answer. So whenever you see the word minimum, minimize, maximum, maximize, you're dealing with the vertex, which is what makes these problems so nice. What if the problem had asked, what is the minimum cost? So remember, the vertex is a point, which means it needs an XY coordinate. Okay, we found that we were asked in the original problem to find the X coordinate, the number of bikes. That's what the question asked us. But what if it had asked us for the cost? Okay, your X is always your input, your Y is always your output. So here, the cost is our output. Okay, the bikes were our input. How many bikes? That was our X, our input. But the Y is really the cost here. The output is the cost. So we use the X coordinate of the vertex to find the number of bikes, but we would use the Y coordinate of the vertex to find the cost here. So all we're going to do is take this 0.7 that we got for our answer and plug it right back in everywhere we see an X. And when we do that, we take that 0.7 and we plug it in, which I did right here. We get 3.156, and then I need to remember to do that same hundreds trick, okay? And so I just jumped my decimal point 1, 2, and that gave me $315.60. So the key to these problems is to remember to use the vertex formula. And once you make that realization, they actually become pretty easy, because it's just a matter of plugging into those two formulas. So if you're asked for the input, you're plugging into the X coordinate. If you're solving for the X coordinate. If you're asked for the output, you're plugging into the y-coordinate of the vertex, so which means you need to find the x first, the x value first, so you can plug it into your function to solve for whatever your output value is. So have fun with these. Let me know if you have any questions. I think you're going to do great, and have fun. Okay, bye guys.